All right, hi everybody. I'm going to do a really quick video here just to run down a couple of things that you should know about today's lesson. If you would pull your notebooks out and title your notes 4.4C Intercept Form. I'm just going to talk a little bit about what Intercept Form is and what it does for us, and then also show you a couple of example problems just to get you started on doing the homework. I think you'll have time in class to do a lot of the homework and then just finish it up for class on Monday. So Intercept Form looks kind of like this, and so what it does is it tells us where the graph crosses the x-axis. So the nice thing here is that we see how 5, 0 relates to this x minus 5 factor, this negative 1, 0 relates to this x plus 1 factor, and then we can use the fact that we have a line of symmetry across the middle of the graph to see where the vertex would be, which is halfway between negative 1 and 5. And then we can use the x value that we find by averaging those x-intercepts to find the y value. So put that in and find out what you get out. If we think about like what we're doing here in terms of the x-intercepts, really what we're doing is the x-intercepts are where the equation is equal to 0. So solutions to the equation 0 equals negative 1/2 times x plus 1 times x minus 5. And so we kind of did problems like this yesterday in class where it was like, oh, well, then I just have to use the zero product property. So it would be x plus 1 equals 0 and x minus 5 equals 0. And so we'd get that x equals negative 1 and x equals 5. So that's kind of what I mean when I say, well, the factors here are showing us what those x-intercepts are. To get to the vertex, we average the x-intercepts. And so we do negative 1 plus 5 over 2. And we're going to end up with 2. So that's the x value. And then what we do for y is we put in 2. So we do f of 2. That's kind of what we talked about last week. But then we also can put those numbers in there. That's really what that means to do. And the math will spit out that gives us 4.5. So that's why that coordinate is to 4.5 right there. So the formula, the form of Intercept Form looks like this. P and Q are the x-intercepts, the way this is written. And then A, just as it always is a vertical scale factor. I know you have notes from before Thanksgiving about what the scale factor does for us. It's the same with this form, so I'm not going to rewrite all that stuff. But remember, stretch compression and reflection is what can happen with our A. So really the task here is kind of doing the same types of things that we've done with the other two forms, the standard form and the vertex form of a quadratic equation. But we have one in standard form here, but we're going to do a little bit of a different thing with this one where we find x-intercepts to do the graph. And we're going to kind of see how it would give us the same answers if we would have just done like negative b over 2a like we did with standard form before. So the strategy here is to factor, because intercept form is also kind of called factored form, and so getting to intercept form is doing factoring. So a times c is negative 54, and so we need to think about the factor pairs of negative 54. I got 1 and negative 54. I got 2 and negative 27. 3 and negative 18. 6 and negative 9. And then I could go to 9 and negative 6. I've got negative 3 and 18, and so on. But the one that I really need is, of course, 9 and negative 6, because that adds up to the right thing here. So we need to use box method to factor, as always. We're going to do our negative x squared here, our 54 here, our negative 6x and our 9x. And again, you could flip the negative 6 and the negative 9. It doesn't matter. Your answer is still going to be the same. I see a negative right here, so I think I'm going to assume that there's going to be a negative there. And it's usually pretty safe to assume there's going to be an x involved. Maybe I'm going to have to put a number there, but I don't know yet. And I know I'm kind of saying I'm doing this in an order that I maybe shouldn't, so I'm going to change it. I'm going to be consistent with the way that I was teaching this yesterday. I'm looking for a common factor between 9 and 54. Definitely 9. 9 goes into both of those. And then 9 times 6 is 54. And 6 times negative x is 6x, negative 6x, and then I just have an x there. So my factorization, factored form or intercept form, is negative x plus 9 times x plus 6. Now there's a slight problem with this one because in the intercept form I had a x minus p, x minus q. And so mine doesn't quite look like that. And so I actually need to factor out this negative and write it like this. If I were to just distribute this negative back in here, then I would have what I started with. And so that's how I know that that factoring is right. And it just cleans up our form and makes it look a little bit more like what we had started with or what I gave you at the beginning of class. So that's why we're doing it like that. So now I can use what I know about how if I'm finding an x-intercept, really what I'm doing is I'm setting this equal to 0. And so when I use the zero product property, I get x equals 9 and x equals negative 6. And so the x-intercepts are at negative 6 and at 9. So that's where that graph is going to cross the x-axis. I see that my a is a negative 1. And so I know that this graph is going to open down. It's going to look like this. But I don't know exactly where everything else is. So I'm going to have to find the vertex. The vertex is the average of negative 6 and 9. So add them up and divide by 2. And I get 1.5. So that means that my vertex is along the line of symmetry, which is at 1.5, kind of like this. Now I don't know what the y value is for the vertex yet, so I have to take 1.5 and put it back in. I can do that way up here with the x's there, or I can do it way down here. That seems easier to me, so I'm going to do it like that. So f of negative 1.5, sorry, positive 1.5, 1.5 is equal to negative 1.5 minus 9 times 1.5 plus 6. Okay, so this is negative 7.5 times 7.5, which is 56.25. So I know that a lot of people are like, well, but the graph doesn't go up to there. Yeah, that's okay. We can go by a bigger number. So what if I went by, tens instead of ones? So now this is 10, 20, 30, 40, 50, 56.25 is right about there. And so now I have a pretty nice looking graph by just sketching like this. I guess it would be good for me to find a y-intercept, huh? How do I find a y-intercept? I do f of 0. That would be 54. And so I should probably revise my graph a little bit because I know that, well, I'm just doing that by looking at this, by the way, too. This is the C term, and so I know that it's 54. But I need to revise this a little bit so that it's a little more accurate. Because it should go through 54, which is right there. So I'm going to just make sure. There we go. Good enough. All right. So when I think about steps, first I factored. Then I used that to find x-intercepts. Then I found the vertex. And then I found y-intercept. And so that's the strategy that I would use to graph these functions. I'm gonna put this one up next. I'd like for you all to try this one before you watch me do it, so pause the video and try this problem, and then I'm gonna walk through it kind of quickly next. So A times C is 45, 1 and 45, 3 and 15, or the negative versions, right? And so pretty quickly I can see that I need to work with negative 3 and negative 15. So this factoring is actually going to go really quick. Negative 3x squared, negative 3x, negative 15x, and 45. Or sorry, negative 15. Well, I'm thinking negative 15, I'm thinking 1, negative 3x, and x. So this can be rewritten as x plus 1 times 3x minus 15. Negative 3x minus 15. Now, this is another time where it's not exactly in the form that we're used to, because there's a 3x, a negative 3x on that last term. So I'm going to factor out the negative 3 and put it on the front. And so now I have that intercept form, which is that I've got a scale factor of negative 3, I've got a x-intercept at negative 1, and an x-intercept at negative 5. So halfway between the x-intercepts is at negative 3, so that means that our vertex has to have the x value of negative 3. And so we're going to put negative 3 in either here and here, or just here and here. I'm thinking the math is going to be easier here, so I'm going to write negative 3 times negative 3 plus 1 times negative 3 plus 5. This is negative 3 times negative 2 times 2. So 2 times 2 is 4, 4 times 3 is 12, and 12, it's going to be positive 12. Okay, so again, we're not really on the graph if I went up by 1, so I'm going to go up by 2s, 2, 4, 6, 8, 10, 12. There's my vertex. I guess a y-intercept would be important for me to know, and I see it right here because that's the C term. So again, if I'm going down by 2s, 2, 4, 6, 8, 10, 12, 14, 15, and then I can mirror that over here too. And now I've got 5 nice points to draw my graph through. This graph is certainly not perfect. It should be a little more curved at the top here, but I'm living with it. Nothing is perfect, so it's all good. All right, that is more than enough information for you to go off of. I should write 12 here. We found x-intercepts at negative 5, 0, and negative 1, 0. We found the vertex, we found the line of symmetry, we found the y-intercept, 0, negative 15. And that's kind of all the stuff that we need to know for this graph to make a nice looking graph. So you have some problems to work through on your worksheet. That is what's going to be homework over the weekend if you don't finish it. But if you do finish it, then you're out. You don't have homework over the weekend. So I hope that goes okay. I will see you all on Monday. Have a good weekend. Bye, everybody.